Okay, so today is gonna be quite a day. So let's just have a quick recap of what we did last time. So let's maybe move in here some window. Okay, so we can draw something. Okay, so what are we working on? We are working on effect cluster. Effect cluster is a library that allows you to implement what's called entity and location sharding, which means that you can have one server running something, and that server is usually called pod. So pod number 1, okay? And over the pod number 1, you can have entities such, for example, user number, user Mattia, that is being processed over this pod, and then we can have other users. Let's say, for example, that we have user Milad. And then what happens is that maybe for some reason this server becomes very stressed with a lot of entities. What you can do is that you can then spawn up a new server that will be able to handle a different set of users. Let's say, for example, that Michael joins. And now we have a new server that is running the user named Mike. So at application code level, ideally, you don't want to care about where the user is being processed. You want to transparently reference the user by just knowing its name. And that's what's called location transparency. Basically, by just knowing that you want to speak with Mattia, you can speak with Mattia. Just by not knowing where Mattia actually is right now, okay? And this ideally can scale to the infinity, because you can spawn up a third server that is running a new set of entities, and that scales up to the infinite. And then when one server is not needed anymore, let's say that, for example, this server goes down, the user will be shut down slowly, and then will be moved onto the new pod, which is the pod number 1, which is a new pod for the entity, but it is the oldest pod that we have in the system, and that can happen in any sort of direction you want. Okay, and so what we did last time what we did is change the way that pods communicate between each other. Because let's come back and say that we have entities living on different pods, okay? Let's say that we have pod number 1 with Mattia Mirad, and we have pod number 2, okay? And then we have some code that needs to call from Mattia details from Mike. So let's say, for example, that there is a particular procedure on the entity named Mattia, then can ask information about Mike, okay? Or Mattia, from its entity behavior, needs to speak with the entity of Mike. So this communication before was handled by in an HTTP API. We had an HTTP server running on both pods, here and here. And this HTTP server was actually part of the pod server. You cannot have a pod without its HTTP server, okay? Oops, sorry. So the situation is kind of like this, where you have different pods, and each pod has each HTTP server embedded in, okay? And when Mattia wants to speak with Mike, what he does is, in the entity behavior of Mattia, we trigger an HTTP request to the pod number 2, and then the request will be processed, and then we will have the response back. Okay? So this is basically an HTTP request. And this HTTP request is called, for example, send message that will actually send a message and get back the result. And right now, this all behave just by using HTTP server. But the idea we are pursuing right now is that why should we be actually tied to being an HTTP server? It can be anything, okay? It can be maybe not an HTTP server, but a gRPC service or whatever you want. So instead of having an HTTP server, we are now migrating to having an RPC server. And thanks to Effect having pluggable context, we can basically plug in whatever we want, as long as it is supported by Effect RPC. So Milad asked, won't it be third pod as a new one when the second pod dies? Won't it be third pod as a new one when the second pod dies? That user brought to the third pod sounds like a replica possible. So you are basically saying that won't it be a third pod as a new one when the second pod dies that user brought to the third pod? It's not actually a third pod. You can imagine the pod as being an application logic server. A pod has only the responsibility of hosting entity behaviors. So basically, the pod is hosting the behavior, okay? But the pod can stay alive ideally forever, should stay alive ideally forever, okay? So when a new entity joins in, is not a new pod, but basically is just joining a pod, is starting a new entity behavior inside that pod, okay? Not sure if I completely understood your question, but feel free to tell me if not, okay? And yeah, basically we want to move away from having an HTTP and having everything as RPC. So we can exchange messaging without knowing which is the actual transport in between. Can be HTTP, gRPC, or whatever. Okay. And last time we did this kind of communication, but we also have another communication which is between the pods and what's called the shard manager. Oh, hello, Gun. Hello, Dark Energy. Hello, Mattia. I really love the effort library. Oh, hope I can learn you a lot from you guys. Hope to let you learn something even today. And so I was saying, okay, we actually have a third kind of server, which is the shard manager. And the shard manager is a server which responsibility is just to list and keep track of the pods that are alive and subscribed to the cluster. So for example, now the shard manager knows that there is entity, the pod entity number 1, the pod that handles entity number 2, etc. Okay, and what happens is that when a pod starts, the first things that it does is calling the shard manager and say to shard manager register. Is basically gonna register himself to the shard manager, so the shard manager knows that a pod exists. So if, for example, we spawn up a new pod, let's say that we have pod number 3, it will call the shard manager saying, please register myself. And the shard manager will then reply, okay, now we are registered. And when the shard manager sees that there is a new pod, the pod number 3 that we have just registered, and that pod has no entity on himself, what the shard manager will do is try to rebalance the system and tell the pod number 1, please do not care about the user named Mattia and please shut down the entity behavior for the username Mattia, because now I want to move the username Mattia to the pod number 3. Okay, so the shard manager is the server that is doing this kind of work. And last time, as I said, we moved this communication between pods, and today I hope to fix eventual issue we have in this communication. Let's hope that we get it running and then move to implement the communication between the pods and the shard manager. Okay, so let's see how we are going. Oh, hi there, Federico. How's it going? So last time, let's see if maybe we start by try running an example. So let's move to desktop, cluster, and then we need to move to packages, cluster node. Right now, this package is one subpackage of the FF cluster, which is called cluster node, but I hope to move that to be something like cluster RPC or cluster platform, so something that is not actually tied to being run on node, okay? Okay, so Milad asked, I read shard on the net, but it seems more related to database, but in your area doesn't make sense. Can you please explain what shard is? Okay, so let's go back to our drawing board, okay? Right now, I always said that we moved entities, okay? We moved user named Mattia, we moved the user named Milad, user named Mike, etc. Okay, you can imagine that in your system you will have something like thousands of entities. Okay, so you cannot imagine having the shard manager being a single point that keeps track of every entity that exists on your system. Okay, so what happens is that what actually happens is that instead of the shard manager telling the pod to start a new entity or shut down a specific entities, all the entities that exists in your system are actually grouped into what are called shards, okay? And what are shards? Shards are just logical grouping of entities, okay? So let's have a real world example, okay? Let's say that we have user named Mattia, user named Millet, user named Mike, and user named Federico. Okay? What actually is a shard? A shard, as we said, is a logical grouping. So instead of referencing each entity, we can say that this is group of entities number 1, and this is group of entities number 2. Sorry. This is group of entities number 2. Okay? But how we tell its user to which group it belongs? So to solve that in a pretty deterministic way, so that each server exactly knows which shard its entities belongs to, the thing that we can do is, for example, make an hash of the user ID. Okay, we can say a hash of Mattia, and let's pretend that the value of this hash is 1. Okay, so now we know that Mattia, the hash of the entity ID Mattia is 1. Now we know that the shard ID for the entity Mattia is 1. Okay, now we can do the same for Milad. Okay, and Milad has the same hash. And now we go to Mike, and we see that Mike actually has hash number 2. So this is a different shard ID. Okay. Not sure if I completely replied or explained well to you, but yeah, you're right. It's usually more related to the database word, because usually database uses shard in order to aggregate entities or aggregate data in order to keep data in groupings or performs optimizations. But in our domain, shards are just used so that the shard manager, instead of knowing exactly each entity each pod is dealing, the shard manager knows just the list of shard IDs, which is a fixed number you can configure in your system, saying, okay, your system will have 2,000 shard IDs, okay? And now the hash will go just up to 200 and nothing more, okay? And so we can have an infinite number of entities that are now grouped into shard IDs, okay? And now the shard manager just manages which shard IDs live on which pod, okay? Okay, I'm happy that my explanation made sense for you. Okay. So back to what we were doing before. We were trying to run the examples, right? And see cluster node and say pnpm example, and then saying something like examples sample manager, because we need to start the manager first. Okay. Okay, we have an error, but this is just logged as debug. And to be honest, this error is expected, because what the shard manager does upon starting is try to contact, let's say that, let's go back to the drawing board and say, let's say that for some reason all of our system goes down, okay? Now everything is shut down. The first thing that can spawn up is not mandatory, but can be the first thing that's spawn up, is the shard manager, okay? And now the shard manager comes back online and says, oh, I know that exists pod number 1, pod number 2, and pod number 3. So let's ensure that they are actually still alive. And now what happens is that the shard manager tries to contact back the pod, and it basically sends a ping, not a ping in a sense of a network ping, but a ping in a sense of a message that is trying to ask, hey, are you still alive? And if the server doesn't respond, as it happened right now, the shard manager will now say, okay, you are offline, you are not running up to now, okay? And so this is expected, that we get the error saying that he tried to post to server that is no longer alive because I didn't start it yet. And then we try to start a new, maybe we can move cd desktop cluster packages, cluster node, pnpm example, sample shard, examples maybe, examples, sample shard. Okay, and now as you can see, I started this pod, so now it's alive. And the first thing that happened is the shard manager acknowledged that this pod is now alive, and basically he moved all of the entities, Mattia, Milad, Mike, everyone, he moved to this pod, okay? Because now this pod is alive and is able to process entities. And as you can see here in the log, we don't see the actual name of the entities, but we see the list of the shard IDs that we spoke before, okay? you can see that basically, since this is the only server in the system, the shard manager decided that, okay, I'm gonna assign you everything. Okay, and now the third thing that I want to start is to start my CD desktop cluster packages, cluster node, not browser, but node. I want to start now something that tries to connect to the entities and send messages to the entities. So pnpm example, examples, sample connect, I think that I called it. Yes. Okay. Now, as you can see, this process is calling the entities, basically is sending an increment message to entity number 0, 1, 2, 3, 4, etc. And each entity has a behavior that just keeps track of the current number and increases. Okay. And as you can see, the actual entity is being processed on the shard process, not into the client process and not into the shard manager. Okay. And now, as we have seen the other times, we can spawn up ideally new processes and the shard manager will balance things between. Like, let's say, for example, that I start a new process again. Sorry if I'm bothering someone that already have seen this demo, but it's also useful because we've moved the protocol so we can see and check that everything is working. And then, yeah, Matrix Love. A lot of text moving on. I need to change the color of the text to be green. And then let's say that I move to desktop, cluster, packages, cluster node. And then I say that I want to start on port 1234, pnpm example, examples, sample shard. So now I will start a new process that is able to host entity behaviors. So this process will be able to host the logic for the counter that right now is running only on this process. And ideally, if I start this one, what we will see is that we have an error. Okay, error, service not running. Ooh, we have an error. Server is not running. What are you trying to ask? And this is why, oh, I see why we have an error, right? We have migrated to effect RPC in order to provide the RPC server. So we have now sharding service RPC that exposes a router, okay? But right now in my examples, the port for the RPC is configured into the sharding config, but then when I start the shard, I start that on a fixed port. Instead, I need to get the port from the configuration instead of starting it right now here. And so that's why we get the error when starting the second process, because we are trying to start on the same port as the first one that is already running. So let's try to fix this. So ideally, if I just, for example, change the port manually, save the code, and run again, now this will use a different port. And you can see that, as I discussed before, the first message will be a register message. That now this port has registered to server. And slowly but surely, the shard manager will basically figure out that now it needs to send things. Let's try to see. Let's see if something happens. Oh no, it's not working because, yeah, because we are not using the correct config. Yeah, we are not using the correct config. So we need to first fix this. Okay, So this is using a layer, and now here instead we need to use a different port. So let's say that we do something like a layer dot flatmap, and we do something like, okay, when we want to start from the sharding config, so we start from sharding config dot sharding config, and then we go effect dot flatmap, and this will go from the config. We need to create the actual HTTP server. So we have here the various things, and we have layer server, layer config, and layer config uses net.list. Oh, okay. So we can use either make, but we'll use a scope, and I don't like that. So maybe what we can do here is say something like, now I have the config, I want to do something like this one, basically. Create layer from, oops, and the port will be config dot sharding port. This will be a map, not a flat map. Okay, and let's see if we have something like layer dot flatten. Yeah, we have. Okay, and what is the expected definition of layer dot flatten? See, flatten layers nested in the context of an effect. Okay, so I provide you what? I provide you a layer, and a tag. Okay, and I get back the that. Okay, so let's try to use that. So from here, now I want to basically get the layer dot we've said flatten, no, not flatten, layer dot, yeah, it was flatten, yeah, it was flatten indeed, but I need to provide the HTTP server, right? Node HTTP server, sorry. Node HTTP server, server layer, and the layer it provides is, oh, HTTP server platform. HTTP, okay, so it needs to provide all of these services. Okay, so I'm not a big fan. Let's see, maybe if we have something better. Instead of using layer, maybe I can use something like make. Okay, and this will create our flattened effect. So I can do flat map, and now we'll have, okay, but now I still have to provide those as layer. Yeah, it would be best just to use layer and then flatten, and we need to have the tags for the HTTP server, which goes from effect platform. Yeah, where is platform? What is platform? I'm missing platform. Platform, oh, HTTP server, I already have that one. HTTP server. Are you fine with that? No. Why? Because it should be should be a layer, okay, and this instead is an effect. Okay, so layer from effect, and this creates this service. I'm not sure the best way to do this one. The thing is that in the end, I want to create an HTTP live, and all of this in the end is void. So I'm just making my life harder, because what I can do is more simple. Is something like maybe pipe effect sharding config dot sharding config effect dot flatmap. What would you active for the test variable? I would like to have something like, I would like to have a layer, the exact same definition that I have right now, as you can see. So I want this to be in a layer that produces nothing, can result in a server error and needs sharding. Okay. I want to have something that is exactly the same, but also require sharding config, because I need to provide that sharding config in here. So I was later thinking that I was doing that the hard way, because what I can do is something like flat map. Now we have the config, or even map is better. And now that I have the config, I can create the layer in here and use the config.sharding port in here, and this will create an effect. Oh yeah, sure. I'll write it in here. I want this to be something like this. Not nested right here. And I want a layer. So this is the signature that I'm looking for. It produces never, so it's discard. It can produce a server error. And then is the sharding and sharding config. Yeah. Yeah, it's really hard when you try to compose a lot of services to remember what you actually want. So this is what I want, and ideally this gives me an effect. So maybe what I can do next is saying that I want a layer dot effect discard, and this should be create a layer of, okay. Oh, I cannot use effect discard. I should have effect, and this requires me to give the tag of the service that is building, and I can use actually whatever I want, right? Effect layer is not assignable to type sharding. Oh, because it's actually producing never. No. Why a layer and not an effect? So the thing is that I could create an effect, and then the effect can be converted into a layer. That's true. That's something that you can do. And that's something that maybe we can start with. We can do maybe server.make, and this we have make, go to definition, we have make here, okay, and this returns the server, can produce a server and as a scope. But the thing is that I want to something to be more composable where I expect some services to be provided by the user, okay. But indeed, if we want to start with something, we can do maybe .make, and this will have what? With the create server, and now it's not effect.provide service. Oh, but yeah, we cannot actually use that. We could, but we would be very verbose, because the thing is that this layer, if you go to definition, you see that it produces a lot of services, and if I convert that to an effect, I will basically all of these to be defined manually. Okay. So I think that I need to see. I'm not very familiar with layers. It's something that I am trying to understand. But I think that ideally by using something like flatmap, I can say that, let's say that I start with the HTTP live layer. And then this will work with, so let's say that I start with this. And I get this. Okay, so this is the config now, ideally, right? Oh, this is not an effect, right? This is the layer I want. Do I actually want to be layer.effect? I want a layer from an effect that consume this, and now this should be the config. No, because this actually requires, yeah, this actually requires the tag itself. So let's start by writing this as the dumbest way I can came up. Sharding config. Okay, and this should be the config. Okay, this is the config, and it's in the context. Okay. Sorry. Sharding config. Okay, and then I want to use this config to create this. So this is a context. So maybe from the context I can get import everything from this context, from effect context. Okay, and now I can do something like context dot get. I want to get the sharding config dot want to get the sharding config, yeah, right? Oh, from the context I want to get the sharding config, right? Or is it not the opposite way? Yeah, is it in the opposite way? Yeah, get, and I want to get the tag. And why are you context? It's not named like that. It's named config. Config. That's why you are screaming at me. You're right. Okay. And this should return the sharding part. Okay. It took a while for me to get it. And in the end, this should look like a layer that produces never can result into a serve error, which means that when we start our RPC server, we can get into an error, and then we can zoom both the sharding config in order to know which port we need the server to start in, and we use the sharding because that is the actual service we are using. Okay, now everything seems to be fine. Okay, so this will actually replace the HTTP live I was trying to write before. HTTP live. Okay, and now ideally, if I do exactly like before and say port 1234, right now, okay, we can see that now it's actually listening on the correct port, not on the wrong one, like as before. Okay, and now you can see that the shard manager acknowledge that now the server pod is alive and assigned some shard IDs. Perfect, it's working, guys. Okay, So now, slowly but surely, we will see that some entities will be moved from this server to this one. As you can see, just the shard ID that contains the entity number 1 has been moved, and now both of the server are doing some work. This is handling only the request for the counter number 1, and now also the 6, which just got assigned as I was speaking, and this one did the other ones. Okay. So, just a moment for a quick sip, if someone has some question, and then we'll go back into coding something for the communication between the shard manager and the actual pods. Okay, so let's stop everything so I won't waste resources. Okay, this is stopped. Okay. Okay. So I see that we also have another issue that we need to fix. That is that a fiber has stopped, but instead we want layer.effect config. Can we just do like this effect config? Yeah, I tried that before, but the thing is that this is not a layer, so you need to convert this into a layer, and I dumbly converted that into a layer by using layer.effect and using the tag itself. There are indeed better ways to do that, but for now that works. So let's start with something that works and then move on. As always, I say that with Effect, you don't need to actually learn all of the APIs. I already know that FlatMap has something that if you give an instance or a box of A, you will get something, a computation. You can chain a computation that takes the A and produces a box of B and obtain a box of B as an end computation that chains all of them together. And that's what I do. I know that I know FlatMap. I know that I can construct a layer from an effect. So I constructed a layer here and then I FlatMap it with another layer. There may be indeed better ways to make this code readable. This is unreadable. I definitely agree with you, but let's start with something and then improve. Okay. So I was saying that I did not expect when I stopped one of the two server everything to go down, because ideally we need our pods RPC. Upon error, it needs to retry again sending the message. Okay. And ideally, I don't remember doing something like please die when this happens. But yeah, let's see. The thing may be that when there are transport errors, we need to see how Effect RPC handles transport errors. Because the thing may be that maybe Effect RPC by default, when there are errors, it goes into a defect. And that's what maybe I don't want. I would want instead to retry again. So let's see, Effect RPC. Let's say resolver. Yeah, it goes on or die. Yeah. Yeah, process effect or die. Yeah. But I don't want to die, because if this dies, okay, then the client fails. So instead of dying, I want to retry. So here when I said log error, I could say that upon error, I want to retry again. So catch all cows, and then I want to log the error and also move that into a failure. I want to move the error into a failure, f.fail of this error. And now this will actually produce a failure of type cause of never. But then I will say effect retry. Or maybe instead of retrying, this API ideally, the pods API, let's say what is the expected type signature, they cannot fail, so they need to retry upon some network error. Or retry while true. Let's move this.
Redefine any definition you got. I had a tag up, make it step to the top. Flames up, we put up, we just gotta hand me the rock. Take a seat, you cannot stand it. All I know the flow harder than a scotch bunny. Don't try to study.
Okay. Papa, why are you not okay with this? Oh, because the retry. Oh, right. Yeah, because catch all goes. Yeah, retry. Well, so instead of doing this, we should do something like effect map error cause, which is also better. We have the error effect.fail error. Okay. Oh, it's a map, so I want this to be a cause. Okay, so instead of map, I want that. I remember having something like that error. Yeah, this accesses the error on error. Yeah, the thing is that I want this to be something that is retried. Yeah, the best way maybe is that I can catch I can catch upon the errors and then move. Yeah, let's see. So here we can have the defects. Okay, so this can computation can die. Okay, this can die. So we provide the environment and we say, okay, if you die, just log it, and then we move the error into the failure channel. Okay, and then ideally this retry, yeah, this should return the type I expected, right? Yeah, void cause. Oh, retry. Yeah. I see. The thing is that retry will tell to retry, but it's not actually. Yeah. Retry is something more like not retrying, but recomputing everything. So I need maybe to write a custom schedule for this. Yeah, I need to write a custom schedule because it's the red sweater. Yeah, this is the red sweater. Yeah, exactly. Oh, by there, for me. This is the red sweater. Yeah, the red sweater that I always use when I go to speaking into conferences. Yeah. Oh, I also have as a complimentary. I have also my bolt cap as a complementary accessory. But yeah, so going back to what I was thinking of is that I have this computation that can go on a die, and I want this to be eventually repeated if we get in something that is a failure, okay? Because this computation, this trait that we provide is something that is expected to be retried upon a failure, okay? So the pods trait is something that expects the transport underneath to retry if something goes on error, okay? So if we have a die that happens for some reason, we need them to sleep and to try again. So maybe the best thing we can do is have a look at schedule. I am not great with schedules, so let's learn about it all together. So scheduling is basically this trait of effect when you can construct by using the schedule API. You can construct things like repeat or whatever, and they can be easily composed. So let's see from the API references of effect, what are the things that comes from schedule, request, schedule, okay? Okay, so we need to have something like, we need to retry, and I'm not sure if we can use like while, delay, specific modify on decision, recur. Yeah, I think that maybe in the effect documentation we have something better than what I'm trying to do. Let's say schedule, repetition, or built-in schedules. This is the one that recurs, repeat, yeah. The thing is that I want to move catch-all cause, E and I, then fail, and then that is fine. And then I want to build a schedule that retries. Yeah, retries forever. Yeah. So maybe you can see something like import everything as schedule from effect schedule, and then effect dot retry, and here ideally it also accepts schedule, okay, and schedule dot retry, it's called forever, I think. A schedule that always occur, producing a count of repeats 0, 1, 2. Yeah. I think that ideally this should be the one that I am looking for. Oh, but still the schedule doesn't erase my my error from the channel. Let's think about it. Okay, I have something that fails with a die. I can use catch-all codes to convert that failure in the die channel into a failure, and then I want to retry on the error. Yeah. I want to retry while true. Yeah. But this doesn't make the compiler happy, because actually this should be something like, maybe there are better options in the retry. Let's say retry schedule options, retry options, retry options. Yeah, we need to do something like, yeah. affect or die. This will make the compiler happy. Yeah. It's horrible right now, but it works. I need to fix this. Control cause, yeah. It's already had the try, yeah. This is definitely horrible to write, but yeah, I need to find a better way to do that. A schedule would be, I think, the best way. I need to first convert the failure and then provide the schedule. And yeah, I need the schedule to be something that basically never outputs the error. But yeah, I will have a look at that next time. I want to first finish this task. Okay, so let's try again the situation we had before. So ideally the shard manager is now running. Okay, shard manager is now loaded. Now I want to run my first shard. Okay, and now the shard has started. Now I want to message with the entities. So I send, okay, and now it's working. Now I start the second shard. It registers itself. Eventually, this shard manager will trigger a rebalance event. Let's see if it starts. Ideally, it should in less than 2 minutes. Yeah, here it is. Here we have a rebalance. Eventually, in the next rebalance, we will have some entity that will be moved from the old server to the new one. Let's see. And 3, 2, 1. Okay, as you can see right now, is retrying forever, but is not able to contact the entity. Oh, and that is actually true. That's actually true, because we don't need to catch all crows. Yeah, we need to catch all defect, because there are only the defects that we need to move into the error channel. Yeah. This I touched, but I shouldn't, because the ping function is expected, yeah, to fail. Okay, so I changed more than I should. Okay, so I say that when we have a defect, I move that into the failure, and I retry when I have failure. Okay, or I die. Okay, same goes for assigned shards. Ping is an exception because ping can fail. It is expected to fail with a pod unavailable exception when the pod is no longer available. And then we also have send and get state that is expected to fail as well. So here, maybe we can just catch all calls. And let's see. Look at the definition. As you can see, the send and get state is allowed to fail. Yeah. And the fail that can have is a sharding exception. Okay. So that goes for the ping. Okay. But the assign and unassign, they cannot. Okay. So here we have, instead of retrying forever, we just move that into something like catch all calls. Instead will be catch all defect in something like defect.fail, sharding exception will be something like pod unavailable exception. Okay, and this requires what? The pod address. Okay, we have pod address. Okay. And ideally, let's try to have a look back at all of them again. Okay, we have assign shard. This operation cannot fail, and it should be retried. Okay. And we have unassigned shard that cannot fail. And then we have ping that can fail, but can fail with a typed error of pod unavailable exception. So we need to catch all the defects and transform them into pod unavailable exception. And we have send and get state that can result in some errors. And if we have some defects, we move that into some pod unavailable exception. Okay. The only thing that I'm not fully sure about is that really true that assigned shard and unassigned shard cannot fail? Let's go back into our methods, assign shards, and let's see where we use those in the shard manager. And if you see it, we actually expect those two to fail. We actually expect those to fail, yeah. So let me see. We expect those to fail, yeah. So given we expect those to fail, the type signature that we have defined are completely wrong, because we said that they can never fail, but they actually can fail. And we also handled in the past that if we have a failure, we map in here, yeah. And here we should have the cause exactly. Yeah, the exception, yeah. Pod no longer register exception, yeah. Yeah. So maybe we can also update the trait, the pod trait right now, and say that this actually can fail, and say shard exception dot pod unavailable exception. Pod unavailable exception, okay. And ideally here we already handled that, and right now what we need to do is just move catch all defect to produce a new sharding exception pod unavailable exception, and the pod address is the one we were trying to message with, and we do not retry, and we do not do nothing. Okay, so what we changed is that now in case of defect, that is because effect RPC produces a defect in cause of some network issue. Now in case of defect, what we do, we catch the defect and we log the defect, and we convert that into a pod unavailable exception. Yeah. And we can do the same for the unassigned. Okay, so moment of truth. Let's try again. We start the shard manager. Okay. And then we start our first shard. Now it's registered to the shard manager. And then we start other shard, and now it's registered. Okay. And then we start the connect, which will send messages. Okay. Right now it seems to work everything. We have some entities, entity number 5, entity number 9 on this process, and all the other one are on this process. So let's try to kill this one gracefully. Okay, now we get notified that there was an unhealthy pod, the one that we killed. And what happened is now our system is back working perfectly. Because what happened is that basically, we can go back to our TL draw if I still have it. Oh, I closed it. Okay. And here it is. Okay. So what happened right now is that we started the first pod, we pinged it, it worked. Okay. And then we started our second pod. Okay. We moved some entities from one pod to another, and then we stopped again this pod. So the shard manager figured out that now this pod is not available, and then the entities were moved from this pod to this pod. That's perfect, I think. Yeah. Okay, and it's not ugly as I thought. Okay, sure, this can be improved because basically all of this is error management. But yeah, and then I think that we are fine. And this work. Okay, let's see what we have changed. We have changed the signature of our pod state in order to account for a pod unavailable exception. And that's fine. And then we changed a little, yeah, our HTTP live in order to actually use the sharding config part. This is not so clean, but we will clean it up later. And then we changed the pod RPC because right now we need to handle the defects and move that into a pod unavailable exception. We didn't touch the ping because that was working before. And we also catch right now the defects with a pod unavailable exception. And that's it. Yeah. So progress. This is fine. It works. Yes. Okay. Going to sync those changes. Oh, what happened? Oh, I see. Yeah. I see what I did. Yeah. I'm gonna fix it later. Yeah. I see. I see. I see. I see. Yeah. Okay. Yeah. I cleaned up something. Yeah. 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 I will fix this later. Yeah. Okay. So we fixed this. And I think that the other thing that I want to start maybe working on is maybe we can fix this issue. Yeah, I know. I want to see what the issues are. Yeah. Yeah, I this one, this one, this one. Yeah. Yeah, I need to fix that one later. Yes. Because I tried something off camera and I break everything as always. But yeah. Yeah, let's keep the current Git branch and do not care about the old one. Okay, so we moved basically the sharding service now to be a router. And I think that the next thing that I want to start tackle is the shard manager protocol, which is also HTTP, but I want to move into RPC. Yeah. I want that to move into RPC. Yeah. Yeah. So let's see how we can start that. I think that we can start by defining the protocol as we did in here by using schema tag requests. So shard manager protocol, I renamed this to RPC. RPC. Okay. And now we need to move. No, I don't want to update it. Okay. And now we need to move those as tagged request. Before we just used plain schema with data. Now I want to use tag request export plus register extends schema dot tag request here of type register and is a register that's not mandatory. The one that's mandatory is here, the tag is affect cluster node shard manager protocol RPC register. And can it fail? No, it shouldn't. For now, let's say schema.never. Or maybe we can just use, let's see if it can or if it can't. Let's have a look. Shard manager protocol. The shard manager protocol uses which services? Shard manager.unregister. Yeah, this cannot fail, and this cannot fail. Okay, so those are unfailable ones. So schema dot void, they don't return nothing. Sorry, the schema dot never, they not fail, and schema dot void as return type, and the fields that we have are just the pod of a type pod.schema. And that's it. And the same goes for unregister. We can just rename that. It's easier. Unregister. We can do unregister. Schema. Okay, oh, we are missing classes. Yeah. Okay, now we have notify unhealthy pod. Notify unhealthy pod of type notify unhealthy pod. And as you can see, those messages are more like notifications that goes from the client to the server or vice versa. The server register itself, or the pod register itself to the shard manager, or unregister himself to the shard manager, or one pod notify that there is another pod that is not able to contact. And there is also, there is get assignment. Yeah, we have assignments result. Okay, we have the API called get assignments. Get assignments, and this returns has an array of tuples of schema option schema. But I think that this was just a workaround because at the time I didn't have find the references. At that time I didn't. Oh, this is actually done. Don't use. Okay. This is not used, so we can just don't care about this and maybe tackle it later. Okay. And then let's go here. Oh, that's why it was not. Yeah. Array from, yeah. Get assignments. Yeah. It's actually an hash map of the shard ID and has an option of pod address. Yeah. Okay, never mind. we actually have that. But back in the days, schema didn't have hash map. Now I think that schema has hash map. So the result now can be schema.hashmap of shard id dot schema dot option of pod address dot schema. Yeah, and that's it. Hash map. Oh, key and value. Yeah, you want an object. That's fine by me. I can say key is this and value is this. Okay, and have as a parameter. Did we send something as a parameter for this get assignments? Get assignments. No, we have no parameters. So we can just remove the pod from here and remove this one. Okay, and this is really nice and clean right now. We can register a pod, we can unregister a pod, or we can notify that a pod is not healthy, is not live, and then we get the assignments back. Okay, so this is basically the protocol for register, ping, or whatever that happens between the pod and the shell manager. Okay. And then we have to implement shard manager RPC instead of HTTP. I don't want to update those. How much time have we left? I think that we have left 20 minutes. Yeah. Okay. So this was my old implementation that relied on Effect Platform HTTP server. But now I want to move to something more similar to this, where I export a router. So I think that I will start by copying the required dependencies from here. Okay. And remove the double one. RPC, pipe, layer, create server we don't need anymore. Sharding manager protocol. Yep. Internal server we don't need anymore. Now we just care about exporting our router. So we need something like this and this. And just copy paste everything because I am a lazy developer, and lazy developer just copy and paste this data. So we have shard manager protocol. I removed RPC, yeah. I removed RPC, yeah. So I can rename this one. Rename shard manager protocol without RPC. Okay, that's it. And then I have shard manager protocol without HTTP. And then I need to handle things like shard manager protocol dot, and we start migrate code from the old things. So what happens when a user asks for a register? We have our register request in here, and what we do is we access the shard manager API. So we access the shard manager API, and then from the shard manager, this is the shard manager, we called the dot register, and we say request dot pod. That's it. And now we need to do the same thing for all of the APIs. So the register we have done, and then we do the same for unregister, which I would say we can just copy and paste from register to unregister. Okay. And then we have notify unhealthy pod, which is called by one pod when sees that another pod is not responding. Notify unhealthy pod, and we have in the request, ideally, request not pod, yeah. But you take the pod address. and same goes for here, pod address. Notify, register. Oh, they all take a pod address instead of a pod. Yeah. So register takes a pod address, pod address, not pod address, pod address. Yeah. So let's change the protocol and say that we have pod address, everything. Yeah. Define LT pod because a pod has both the address and, if I remember some correctly, also have things like diversions. Yeah. But we don't care about that. Okay. So let's say register requires a pod, but unregister and notify requires a pod address. So we can change the protocol to just require register pod address. Okay, and here we have a pod address. Let's rename this as pod address. Pod address. And now here, instead of doing this dance, we do pod address. Pod address. Okay. And the last thing that we need to implement is get assignments. And guess what? Copy paste, get assignments. We have the request. We call get assignments and has actually no data in the request. So I actually don't care about it. And that's it. We have now our router that handles this kind of requests and requires, in the effect context, a shard manager in order to construct a router. So we can call this shard manager RPC. And then shard manager RPC request. So we're saying shard manager RPC request. And then we don't need anything more from here. Everything dies and goes away. Okay. We can also remove these dependencies that are not required anymore. And that's it. Okay. And now we need to create the actual client. So shard manager client RPC. Yes. Maybe I want to sharding shard manager service RPC maybe. Yeah, I want to name this to something like service RPC. Yeah. Shard manager service RPC. This seems something more fitting. And then I want shard manager client RPC. Okay. And this is basically the same thing that pods does. But the thing here is that here we actually know that the shard manager URL is fixed. Okay. So instead of doing all the dance that I did there, we can make it more simple. But I still need a way to create a client. Yeah. So I still need to have a way to say that I want to create a client that is agnostic of whatever are the protocol of the RPC. Yeah. So I can do something like rename this old one for now and say export function and shard manager client RPC, and as a parameter, this will take in some function that will create a client, and the client will be something like that. Client will be something like, I already have it there. Yeah. So the client is a function that, when called, will actually given a request of type sharding manager protocol, not HTTP but RPC. Given a request of this kind, RPC request. Okay, will return the request result or success. Okay, I need to import request from effect request. Okay, and it's not called shard manager service, shard manager protocol. Yeah, shard manager protocol without RPC. Yeah. No. Rename symbol. Yes. Okay. Shard manager protocol request. Right. Shard manager. Oh, because I need to import those for yeah. Shard manager, because the thing is that with effect RPC you need to import the typings from the actual router, not the protocol. The protocol are just the messages, the single messages. Okay, those are the messages, and then I have the service RPC, which creates the router and the types for the router, and the same goes in here. And then in the client I need to import shard manager service RPC, shard manager service RPC request. Okay, now it makes sense. Okay, perfect. And then here I create a new layer .effect that can go in the same way, same exact way. Yeah, and I say return this. Okay, but here I will say that I do not have to create a client. I just need to access the config. Okay, and yeah, oh yeah, to be honest, I need this to be a function like make client that takes in the shard manager URI, shard manager URI string, and then what I will do is that upon a register I will then client, I need to make client by passing the config dot shard manager URI, and this is not an effect, it's just a function. Okay, and then I can do things like register is just calling client and new sharding shard manager protocol, not HTTP. I need to import that shard manager protocol, and then call shard manager protocol dot register, and the pod is, oh, I actually forgot that I needed to look what it was before. Yeah. What it was before? Shard manager client HTTP. Yeah, it was something like pod.make. Okay, pod address config.server. Okay, so it was like this. Yeah, it needs to register and needs to unregister. Okay. Oh, the pod is this, and void never r is not assignable to type void never. Yeah, because I said here r, but I actually don't want r. I want never. Okay, that's fine. And then cannot be used as value as important. That's not true. I want this as a value. Okay, and that's it. And the same goes for all the other requests that I have. So unregister, as you can guess, is the same thing, but goes unregister and doesn't require a pod, but a pod address. And then we have the same for notify unhealthy pod that uses notify unhealthy pod. And then finally we have get assignments. Okay, and this actually what does is assignments. Okay, schema is JSON, response is just calling the method and returning data. So get assignments will be just something like client new sharding shard manager protocol, yeah, dot get assignments with no parameters. Yep. And we need to remove this piece of old code, and that's it. This will die and get removed. Okay, are we missing a semicolon? Yes, we're missing a parenthesis. Okay, and semicolon. Yeah, so this function takes in the shard manager, the make client, which is basically given the shard manager URI, I will build client. Okay, and then uses that client that can handle this kind of requests to actually call the function over the server. And then it's fine. Perfect. Now we need to remove some unused imports. That's it. And then let me just lower the volume of the music. Okay. And then what we do here is the shard manager client is ideally completed. So we did everything in here. We need just to update the examples, I think. Okay, so now it's not HTTP, but it's shard manager client RPC. Shard manager client RPC. And we need to now make shard manager client RPC. Shard manager client RPC. And this will take in a shard manager URI, and we need to create a client with that. Oh, I also already asked about better typings for this to team. So I need to update this one because I actually know what I need to do. And here I need to actually call the shard manager URI. Perfect. And that's it, I think. Yeah. And this piece of code goes in here and here. What do you need from me? What are you complaining for? Oh, we have some error, yeah, but that is because right now we changed something and now we need to update it. Share manager client RPC. Share manager client RPC. And we need then to update this one. And we are fine. Okay. So what's bugging you? What are you not happy with? Okay, so here are you saying, oh, shard manager HTTP? No, it's shard manager R client RPC. Shard manager service RPC, yeah. Shard manager service RPC. And here we need to do the same dance we did before with the HTTP live, but for the manager. Ideally, this part of code that I am building inside of the examples will be something provided by the library. But yeah, I need to import create server. I need also to import few things. I need also to import manager config, I think. Yeah, I already have manager config. Okay, HTTP server, HTTP client. Client already had. Okay, HTTP router, HTTP router resolver from RPC HTTP. Yeah, makes sense. And instead of being sharding service RPC is now shard manager RPC.router. Yes. And what I'm still mixing, node HTTP server and context. Node HTTP server. Okay. And the context. And that goes from manager config dot manager config dot API port. Yeah. Yeah, API port. Yes, that's it. And we need now to provide, in the same way we do here, we need to provide HTTP live. Yeah. And we start with tortured inside my mind. This darkness left in me. We have an effect, and we try to provide HTTP live, which requires manager config and the shard manager. Okay, so shard manager.live, it's in here, and manager config we have in here. Okay, so you should be fine. All right. HTTP layer requires what? Requires manager config and a shard manager. Okay. Yeah, we need to fix those examples. We have horrendous code in here. Yeah, we need to fix those. Yeah. I definitely need to fix those. Yeah. Okay, so instead of doing something like layer, yeah, we did scope.discard provided it's be live, yeah. Yeah, maybe we can do a layer.scope discard. Okay. This fixes it, but we need to improve the examples indeed. Oh, hey there, Jean-Baptiste. Nice to meet you. How's it going? So, right now, we should have fixed everything, and we should be using effect RPC right now. So, let's start. Let's start the shard manager. Okay, the shard manager is listening on port 8080, perfect. And then the shard manager is listening on port 8080. Yeah, but I think that in the manager config, alongside of that, we have the API port. Yeah, that's fine. Oh, it's really your first time on Twitch ever? Hope that will be some good memory for you. So we are working on effect cluster, and as you can see, I have horrendous example because I am in the middle of refactoring. As I have discussed, I had an architecture that relied on effect HTTP in order to speak with different pods, and now I want to migrate everything to use effect RPC instead, so I can use whatever protocol you want. And I am in the middle of testing if everything worked. But by the mean of things, I see that here I expected something else, because I see 8080 is listening on port 8080, but ideally the default config for the client says that sharding config. Oh, we also need to prepend something else. Yeah, it's 8080, but we also need to prepend API REST. Yeah, okay. Because in the shard manager config, I have that. Yeah. Okay, shard manager, I own shard manager config. Where is manager config? Yeah. Yeah, I only have the API port. Yeah. Oh, yeah, but I don't. Yeah, it should work because. Yeah, let's see. Let's try. It's easier to try. Yeah. Now we have a shard. Yeah, the shard started and registered itself. So we did the handshake between the shard manager and the pod that we just started. They registered himself. Yeah, okay. Perfect. That's really, really perfect. Okay. And then we want to start the process that sends messages. Let's see. And it's working. It's asking the pod. Okay. And then let's start another pod on a different port. And it registered itself. It received. It's perfect. That's really, really perfect. This has new shards assigned. Yeah. And the process that was sending messages is still sending messages right now. So if I stop the first shard manager, I should see that now here is retrying forever. Okay. Until now the shard manager figured out that one pod is not alive anymore, and slowly but surely it's moving all the entities over the new pod. So let's see. Yeah, as you can see, it's moving slowly but surely the pods. Yeah, it's working, guys. Yes. So I think that unfortunately for you, Jean-Baptiste, you joined quite later, unfortunately, but you can still see the VOD of the recording of the session. And what we accomplished today is we finally moved everything away from effect HTTP, and we now rely on effect RPC. So that means that we could also, and that could be very interesting. I know that there is someone that is very interested in this. Run a cluster inside the browser between different workers, because now we are not tied to having this one being something HTTP. It can be, for example, post message between two different windows. And it should work, ideally. So this is something that we will work towards in next streams. So move into a browser environment and everything work. But yeah, I think that we have been streaming for almost 2 hours up to now. So yeah, I think that I'm gonna have lunch. And thank you again to everyone who joined. Hope you had fun. Hope you learned something. As always, we will see you next Thursday, I hope. And then thank you very much to everyone. Hope that you have fun. We have finally moved to Effect RPC, so can't wait to work next week on cleaning up all of those dirty examples we have right now and have something that works better. Thanks again, everyone, for joining, and see you next time. Bye bye, everyone.